Hey everybody, I'm GT, Gran Turismo.
Hey, I'm Marcus. That makes me think of the PlayStation game, Gran Turismo car racing.
Yeah, that's where GT is, man. Fast and sleek and racy. That's why I named myself that. No, man, that's terrible.
I like it.
Yeah, the only reason I even said Gran Turismo is so it made it where you didn't have anything to make up to say GT, because it's always terrible. Let's see, some of which we can't even name publicly. All right. Last video we talked about collect, getting the data, switches and access points. Then the last video was transport, getting that data to the cloud. So now imagine data's worked its way through the interwebs, bam, hits up against the cloud. Now what's happening? There's three processes we're going to talk about. First one is ETL. I don't know what that stands for. The next is compute. And then the last is storage. So we're going to hit those bam, bam, bam now.
Yeah, so the data has been pushed to the cloud. And like we talked about in the last video, it's in a message bus or message queue, waiting to basically be ingested by the cloud. And so there's this term ETL, which stands for extract, transform, and load, which is basically... it's like an old term from the 70s. I'm not sure if anything good came from the 70s.
This guy.
So it's the meaning of ETL has changed quite a bit, but what it basically means is we're just taking the data and we're doing something with it to make it more useful.
Yeah, so when we talked about this before, I think of a web form. So when you, and everybody out there, when you're typing in a web form, you put in your name, first name, last name. Those are just kind of generic. But then there's like phone numbers. You type in your phone number and your email address. Phone number is a really good example because I use a dot. So 501 dot. I'm not giving you the rest of my phone number. I can't get more text messages. Not that anyway. I know no one would actually text me. But the dots. Some people use dashes. Maybe people use nothing. For you international people, you're always used to doing the plus whatever. As Americans, we're kind of snobby, so we don't do any plus ones or anything like that because we just kind of think we own it all. But yeah, so that data has to be converted or normalized or something into something that's all the same. So no matter how Marcus or I or you type in your phone number, in the end, it has to be the same, whether it's a string or an integer or all these other things I don't really understand, but it has to be the same in these databases so something can be done with it. And ETL is a big part of that, is that process. It does a lot more, but that's one of the things the ETL does.
Yeah, I think for those of us that are not like database admins or experts or even data engineers, it's easy to think of like data in a database as just kind of like out of sight, out of mind. Like your phone number is your phone number, your name is your name. Like there's nothing else to it. But like to a data engineer, ETL is not like the sexy stuff of like machine learning and AI is kind of all the sexy stuff people want to talk about. But the data engineering of ETL, getting your data to be right, discarding bad data, normalizing data so that it's the same, transforming it into something that's usable. Like this is like the guts of like data engineering and making data useful, but it's also like the tedious, non-sexy stuff at the same time.
Yeah, I'm just slightly offended that you assumed that I was not a database expert.
Oh.
I will have you know that I was a MC, Microsoft Certified Database Administrator, MCDBA, for SQL 7. So this would have been 1999-ish. So I actually am, obviously, a certified database expert. So just watch yourself next time, youngman. Does that mean that you were born in 80? Or were you born in...
I was.
You were not born
82.
in... Oh, my goodness, man. That's just... that's,
dude, you should...
But like 7 years ago, I looked just like you. So it's just time that did this to me. It wasn't genetics or anything. You should
update your LinkedIn, man. Like GT Hill. You know how people put like CCIE? You should put whatever that was that you said. I don't even know what that is.
MCDBA SQL 7. If I'm going to do that, I'm going to do MCSE plus I Windows NT 4. There are people watching this going, oh my goodness, they don't even know what that is. Yeah, it's like, this is before.
You should do it.
I could do that, yeah, because my job opportunities are just hitting me left and right anyway. I might as well get rid of some of them. Anywho, let's get back to this. So we have all heard this term garbage in, garbage out. So data is garbage in, garbage out. But ETL is actually a little bit different. ETL is a process to take garbage in that, remember, from a database perspective or a data perspective, things that have the dots instead of the dashes and are strings instead of integers and all that is different. If you take all of those differences and just throw them into something, that's bad. That is garbage to a system, to a computer system, compute. So that has to be fixed, and that's what ETL is doing. So it's actually garbage in, goodness out. That's the ETL process, I think, maybe in summary.
Yeah, and we focus on like this transform stage of ETL now, and in like that, so there's all these like data terms that people throw around, like joining or like merging data, deduplicating data, aggregating data, which is like calculating averages or sums from groups of data, or like normalizing data is kind of one of those vague words that we all hear about, like, oh, it needs to be normalized, but we don't know what that means. Or like anonymizing now in like security conscious world that we live in today.
Yeah, I think deduplication is a really good example. If you think about your traffic, Marcus, let's pretend your network is all extreme. So the data hits your access switch and then your distribution and then your core. That data is all hitting switches. When it gets back to the cloud, the ETL process can say, look, this is the same, and it always is the same. So I'm going to only keep one of these instances because it doesn't make sense to have all of them. So we're going to save the data, save space in the database, and deduplicate that. So that's a good example.
Yeah, or like, like with a lot of machine learning tasks, like natural language processing, and this is something that like Giacomo's one of our PhD, data science, super smart engineer guys, is just kind of educating us about, is like when you do machine learning tasks and you compute the data, you might have to do ETL to transform, like, let's say, like a text document that you're going to run through natural language processing. You might have to strip out page numbers and headers and footers, and you might have to change certain terms and verbs and words and subjects and normalize contractions and do some of these different types of things so that it's processed in the right way. Or like video or image processing, with machine learning, getting everything into the same file format, the same resolution, the same image size, all of those types of things are like ETL tasks, so that when you run it through that compute ML algorithm, it's like you said, good data going in so that the machine learning algorithm can do its work.
Yeah, these processes are a little bit, we kind of put computing and computers on a pedestal a little bit, like they're so smart. But relatively speaking to what we're going to see in 10, 20 years, they're not. Like today, the compute process that we're going to talk about almost has to be like a child. Like, you don't use contractions, and you make sure everything is kind of formatted good when you're talking to a 2-year-old. That way he or she can understand you better, and eventually we'll understand more of that. But again, that compute process really kind of has to have stuff aligned for it, and compute just happens to be our second topic for the day.
Yeah, and I think the word compute is it's a little too vague, but like what we're talking about here is like, ETL and compute sort of go together and it's one thing, but we're teasing them apart. So ETL is kind of like this pre-processing to get the data ready, and then the compute stage is where we're applying some type of machine learning, data processing, additional basically processing into the data to get some value out of it. So it might be the process of building a machine learning model, or it might be running data through an anomaly detection algorithm, or doing something like that, which is what we mean when we say compute. Compute is a huge, massive topic, and so we could spend a lot of time. This is its own video series, just this compute stage, and so we're going to do that. So we're kind of skimming it a little bit here, but that's because we're going to come back to it and really anchor in on that topic in a few videos.
Yeah, as a little bit of a teaser, think of compute as the mold. In some ways, one of the things compute does is, if you imagine an iron ore process, that's ETL. It takes the iron ore and it turns it into good metal. Think of raw sheet metal to use. And the data model is something called a data model, is the stamp. So boom, we're going to stamp out fenders or car hoods or something. And that's a data model. It takes something raw in and then has an output of something really good. But then what has to happen through all of that after that compute process is it has to be stored. Now, of course, compute has its own storage, but there has to be a specific kind of storage. Now, when I think storage, I think, hey, if I need more storage, I go down to my local store and I just get another hard drive, right? I'm going to get more storage. And
Yeah.
so I don't think so much about how I organize data or how I store it, but definitely for cloud applications, when you have tens of millions, literally billions and trillions of pieces of data, the way that it's stored is really, really important.
Yeah. Well, and that's where you'll see in modern applications, you have this variety of data that's existing now. And so there's specialized databases to handle variety. But in general, there's like all these purpose-built types of databases that solve certain types of data. So like structured data, it would be like, SQL, like inventory data, configuration data, admin accounts, licensing, structured stuff that fits a standardized schema. This is like your typical Excel row and column, like it fits a structure. But then there's like semi-structured data that's just like time series telemetry data, or unstructured data like files, videos, images, other things that don't fit into some strict schema. So first thing we have to do is solve for this like variety of data types problem. And so we do that by typically introducing different types of databases. Like for us, we use Postgres for structured data, Elasticsearch for like semi-structured telemetry types of data. We use, other databases for like high-performing cache data, which is like, a separate side of the database equation as well, is like how often you need to access the data.
Wow, those are really boring terms. I mean, that's exciting, dude. That's cool. So, no, let's do. So I've spent an hour or two in a kitchen, as you can tell. So when you were talking about this, I think of structured versus unstructured. I think of normal humans, all of you that are non-serial killers out there, you have a silverware drawer that has an organization that you keep perfect. So the forks go in the one place, knives. Big spoon, that's me. Little spoons go in a different one. That's a drawer. Now that drawer is really good because it's easy to access. You open it, you grab the fork, you know where it is all the time. The downside is what? It's not very efficient. So that drawer can actually hold a lot more stuff. So then you have the opposite of that, which is the junk drawer. The junk drawer has your AAA battery that one that you're missing that you need, and it's stuck in the back. So you take all the stuff out, you find it, or that thumbtack because you ran out of the 3M sticky stuff. I actually think 3M and their fancy stickiness has actually put the thumbtack. I think thumbtacks are going away. That's my trend. That's my. If you're in the thumbtack business or you have stock in the thumbtack businesses, I think you should consider selling your stock. I don't know if that makes no sense. Anyway, it's okay. We can give stock tips on this. I think that's a valid thing for us to do.
We need sponsors, 3M.
Yes, this is sponsored
by.
That's a great idea.
We had to find a way around to 3M. But what you're saying is the way that I think about it in a kitchen is like, what you're saying is there's quick access to certain types of, tools, instruments, or data, in the kitchen. But like storing data in the kitchen is expensive because you need fancy cabinets and you need more countertop space. And so it's expensive to store it in that high performant, readily accessible, format like silverware. There might be like appliances like a bread machine or something. You use that example in our conversations. You might store that in the garage on a shelf because first of all, it's just expensive to store it in the kitchen. But second, you just don't use it very often.
Performant? Are you saying the word performant?
Yeah.
I actually thought that was a typo in our notes.
High performance.
So that's a real word.
Yeah.
Man, I learned lots from you, man. I'm glad you went to college. See, that just avoided me having to go to college because I just get to learn stuff from you. So speaking of the cost you were talking about, I love the analogy that you were talking about, which is, the bread maker, which appliances should never be on the countertop. I have it in my house, but it drives me crazy. But they should be stored elsewhere that's cheaper because you're not using them as often. So that's good. But data is still expensive to store, especially when you're dealing with as much as you are, which makes something that Extreme did is made the cloud data unlimited. So if you're a customer out there or a prospect customer and you create a instance of Cloud IQ, we nickname that XIQ. If you have that, you actually get unlimited data storage as long as you are a customer. And that's incredible because that data has a ton of value. You may not use it today, but maybe your boss says, hey, it'd be so great if we actually had trend data for the last 3 years of how many people were doing X, Y, and Z on our network. Boom, you're the hero, right? Now you're a rock star because you can just pull that data out and actually do something awesome with it. So again, super plug for my brothers and sisters at Extreme that did all the work to get that done. That's an awesome thing to be able to have that unlimited data.
Yeah, I love that. And you know, it really just kind of connects to why we're doing this whole data pipeline thing. It might seem a little in the weeds for those of you that are following with us, and we appreciate it. But you know, data is the currency of the future. And so, you know, I don't know, maybe that's a little too like buzzwordy to say something stupid like that, but there's just a truth to it, which is like data is value. And so we're trying to help find ways to translate that value. So again, in this video, we talked ETL, compute, and storage. In the next video, we're going to translate and wrap up our data pipeline before we move on to machine learning. But we're going to talk about sort of actions and applications of data and what comes after storage so that you can actually get value out of your data.
Yeah, lots of good ways to get it out. So I'm looking forward to that video. Thanks, Marcus. You're a rock star as always.
Thank you, man.
Thanks,
My
everybody.
pleasure.
Appreciate you watching.